This lesson is for Chapter 1, Section 8, Other Types of Inequalities. It is our final section for Chapter 1, so our test will be coming up in just a couple of days. So, we're going to be taking a look at inequalities again with this section. To solve polynomial inequalities, you're going to need to find your zeros of your inequality, very similar to finding polynomial solutions for equations. But since these are inequalities, we're looking at greater than or less than statements. So we're not going to be coming up with a number or just a couple numbers that are solutions. We will be finding intervals of numbers. So these zeros of the inequality are places where the inequality will change from a positive amount to a negative amount. They are going to identify for us those intervals in which our solutions are going to lie. Now these zeros are called the key terms of the inequality. Right, so we'll be talking about finding key terms. If we were going to take a look at solving this inequality, it is easy enough to factor this one, so that's the fastest way to solve. This quadratic factors into x minus 5 and x plus 4. So our solution, or our zero, for our first factor is a positive 5. And our solution for a second factor is negative 4. And these are going to give us the key terms, which will break our possible numbers into intervals for us. So negative 4 is our smallest key term, which means we're going to check our digits from negative infinity up to there, and then from negative 4 up to 5 in that range, and then also 5 to positive infinity. Okay, so the book suggests, and I kind of like, making this chart to organize our thoughts. So let's say we were in that first interval, negative infinity to negative 4. Pick a random number. Pick any number that's less than negative 4. So I'm going to put in a negative 5, which then, if substituted into our inequality, gives us a negative 5 squared minus a negative 5 minus 20 is less than 0, which is 25 plus 5 minus 20 greater than 0. Now 30 minus 20 is not greater than 0. So that solution from that interval does not satisfy our inequality. There are no solutions in that interval of negative infinity to negative 4. Our second interval goes from negative 4 to 5, so I'm going to pick 0 just because it's the easiest one to work with. So I have 0 squared minus 0 minus 20 less than 0. And that results in negative 20 less than 0. And yes, it is less than 0. So there are solutions in negative 4 to 5. Okay, all of our real numbers in between those two digits satisfy our inequality. Our third interval is 5 to positive infinity, so I'm just going to pick a 6. So 6 squared minus 6 minus 20 less than 0. 36 minus 6 minus 20 less than 0. That's 10 is less than 0, and that is not correct. So the interval in which our solutions fell was negative 4 to 5. So let's just put a couple of digits on our number line here. So if we're going from negative 4 to 5, parenthesis bracket at negative 4 and 5, and shade in between, indicating that all of these numbers in here are solutions. Okay, hopefully that wasn't so bad. My board does not want to go to the next one. Hang on. There we go. Now, solving a rational inequality, That means that we're going to also have fraction pieces in our less than, greater than statements to solve. When we are going to find our intervals here, we're looking for zeros and also undefined values. So the zeros are when the numerator would equal 0, and undefined values are where the denominator would equal to 0. So let's solve this one. First thing, we want to rewrite this fraction in general form, which means move everything over to the left. So x minus 2 over quantity x minus 3 plus 3 is greater than or equal to 0. Now we need our common denominator. So we're going to multiply 3 by x minus 3. All of that will be over then our common denominator. All right, so we start simplifying. Distribute your 3. And simplify. 4x minus 11 over the quantity x minus 3, greater than or equal to 0. So the top, find our 0 for our numerator. So 4x minus 11. So our numerator will equal 0 at 11/4. The denominator. The denominator is undefined at 3. So here are our intervals. We're going to have negative infinity up through 11/4 to check. Then 11/4 to 3. And 3 to infinity. Now, please go ahead and set up a table like we did on the previous slide, and you get to pick any value you want from these 3 intervals. Now, the tricky one is going to be that second interval, 11/4 to 3. You're going to have to pick something between 2.75 and 3 to plug in there. But you've got your calculator, so, pick something like 2.8 and put that in for your value for that interval. Now, as you do that, you'll find that our solutions end up working out or testing positive in the, let's see, which one? In the first one and the second one. Okay, so from negative infinity to x over 4, and then also from 3 to positive infinity. Okay, so graphing that on the number line, again, if this was 11/4 down here, and we wanted to graph 11/4 to negative infinity, we'd have the parenthesis here, and extending to the left, and then 3 would be up here, parenthesis at 3, the bracket there, and then arrow extending to the right. Okay. Now in interval notation, we should also talk about how to state this answer. We would end up with this interval in union with this interval, because all of the numbers from both satisfy them. Okay, so that's how you would write that in interval notation form. I think I'm going to skip that one. It's just like the previous one.
Juniors, magazine sales or your dues of $25 are due today. Please bring them to the office. Cole Watsky, please report to the office. Play practice for today after school is canceled. Michael Lee, please see Mr. K. And play practice tomorrow will be changed to 4:30 to 6:30. And just a reminder that tomorrow is Lake Orange / Camo Day. Also the theme for the home volleyball game tomorrow night. Make sure to show your Tiger spirit and dress up. Also a reminder that the 9th House Grade Dance will be held this Friday, October 3rd after the game.
Sorry, we're competing with our end of the day announcement here. All right. right, so I'll try to talk through it because this is going on for a while. I looked at the one application problem on page 145 in your textbook, talking about revenue and cost and trying to ensure a profit. So there's one right above it that is similar to this. But in just all logic and thought, a profit is earned when your revenue is higher than your cost, correct? So if we're trying to find a profit of $3,600,000, okay, we've got to have the subtraction or difference between that revenue and cost to be bigger. So if we're trying to go with $3,600,000 at a bare minimum for our profit, okay, we want that to be the smallest possible. Okay, so that's going to be offset with our revenue expression minus our cost one. Okay, we want that $3,600,000 to be bigger than what the difference between those two is. Okay, so now it's just a matter of doing some distribution and some simplifying, so see if you can't follow me through that. Distributing the x here, we now have 60x minus 0.001x squared minus 12x plus 1,800,000. Bringing everything over to the left-hand side so that our x squared is positive, we're going to have 0.0001x squared. The 60x and the minus 12x make 48x, but bring it to the left, you're going to have negative 48x. And then bringing the 1,800,000 over, we are left with a positive 1,800,000 after it's subtracted from the 3,600,000. All right, now, oh wait. Shoot. Sorry guys, back up here with me a little. We need to subtract our cost equation, which would have been a subtraction of, sorry about that, subtraction of that, which then when we bring it to the right-hand side, we add it there. That looks better. All right, so sorry about that. Please change that one number on your notes through there so that we're all looking at 0.001x squared minus 48x plus 5,400,000 is greater than or equal to 0. Now, that one may very well factor. I'm not sure. But I thought this one was more appropriate just to put through quadratic formula, and it did turn out beautiful. Okay, so all is said and done, I got down to this. 48 is plus or minus the square root of 144 all over 0.002. 0.0002, which of course the square root of 44 is a perfect square. So that was 12. So 48 plus 12 is 60 divided by 0.002, and that resulted in 300,000. 48 minus 12 is 36. That resulted in 180,000. So we want to have our units end up falling in between them. So end answer, 180 is the smallest one, so begin with that. We want our units produced to in between those two values. All right. One last thing. If my board will go. Get my mouse, sorry. I don't know what's going on here today. All right, the last thing that was brought up, and I thought I would review, we've talked about it a little bit. Remember that domains, okay? Finding a domain is finding all the values where an equation or expression can be defined. So if you're looking at one like this that happens to be a radical expression, in order for an expression to be defined or real, you can't have a negative square root. All right, so let's take a look at this one and factor that inside. Okay, so answers here are going to end up being, to find us 0 here, a 5 would create a 0 underneath that radical sign, and a 2 would create a 0 underneath that radical sign. Okay, so when we're looking for finding that domain, we're looking to identify these pieces that create those zeros in the expression. Okay? All right. I think to state that in interval notation then, if those are our breaks, check. Okay? So those are what make our square root 0. And that's okay. Okay, square root of 0 is 0, so we're okay with these two numbers. But let's look at negative infinity to 2, 2 through 5, and also 5 to positive infinity. Okay, if we go with, say, a 0, and we plug 0 into our radical, we're going to get 0 minus 0 plus 10. 0 squared minus 7 times 0 plus 10, 10 is positive. That's okay. All right, so having that value in that interval negative infinity to 2, we're just fine. Randomly pick something out of the 2 to 5 interval, maybe a 3. 3 squared minus 7 times 3 plus 10. We're going to get 9 minus 21 plus 10. That's negative 2. Remember, we cannot have negative values underneath our radical sign in order for them to be defined. So this interval right here, those numbers are not going to work. Now 5 to positive infinity. What a mess on that one, sorry. My pens are not working great tonight. Positive infinity, let's pick a 6. We throw 6 squared in there, we've got 36 minus 42 plus 10. We're going to have negative 6 plus 10, which is positive, and that's okay. Okay, so as long as we avoid that interval between 2 and 5, we have valid solutions. So interval notation for our final end answer, negative infinity to 2, along with or united with 5 to positive infinity. And there I think we got it. Now, for your assignment today, you guys turn to page 147. I encourage you to do a lot of the odds for practice and understanding, but I am going to ask you to turn in 5 problems, and they're listed on this slide here. So I would like you to do 10, 14, 30, 42, and 78 on a separate sheet of paper. Turn that in for me so that I can check those. All right, that is it. Well, I kept it under 20 minutes, not too bad.